Okay, we move on to question 6 of the paper, and question 6 was a nice geometry question. Let's have a look. Remember, have your pens, your coloring pens ready now, because we are going to indicate different relationships on our diagram. So I've got my blue, my green and my pink. Let me start with the blue. Two circles meet in A and B. Point A and point B are the points of intersection of two circles. So that is a common chord between the two circles, folks. Now remember what you've learned. You've learned that equal chords subtend equal angles. So we could have said that angle C1 is equal to D1 if these two circles were equal in radii. We do not know that, so we cannot say it. Okay, let's see. The only thing we can do is check if they tell us two circles meet in A and B, is the common chord drawn. If the common chord wasn't drawn, I would have advised you to draw it in, but it's there. Okay, so let's park that for the moment. BD is a tangent to the circle passing through A, B, C, and E. We stop reading. BD is a tangent. The angle, carefully, the angle between the tangent, there's the first chord, the angle between the tangent and the chord, take your finger to the chord, is equal to the angle in the alternate segment, which in this case will be C1. Or it could also have been E2. Look again. There's the angle between the tangent and the chord into the circle. That's equal to the angle in the alternate segment. Or alternatively, we could have argued these two an equal tan chord, those two equal angles in same segment idea. Okay, let's move on. So we've got this is equal to those two angles by the tan chord theorem. This is a tangent. Now be careful here. They also immediately gave us that these lines are parallel. They've put the symbols on there, and we can see that later on they just remind us the lines were parallel. So before we forget it, let's make these equal to each other. Why are they equal? Well, there are the parallel lines. Here's the transversal. So the angles are lying on opposite sides of the transversal. So what do we call them? We call them alternate angles to those two parallel lines. Okay. Then immediately I can see there's a cyclic quad. Okay, angles in same segment are equal. So all these angles indeed are little x's. Quite nice that they said that, they gave us that. Okay, so we've used the parallel lines so far, and we've used the idea of the tangent. Let's read on. AB is a chord to the second circle. Well, yeah, we've established that right at the beginning. DA is produced to E. That's important. If DA is produced to E, it means that there, from E to D, you actually have a line segment. Now, why is that important? They made notice of the drew your attention to the fact that that's a straight object. That is a line segment, which by definition is straight. Remember what I showed you earlier on in the years? That if a line is given to you, or if that is given to you, they made a point of saying it's produced, it means it's straight. Then you start looking for exterior angles. So I'm going to go over to my green pen. This here is a cyclic quad, by definition, because there's 4 points on the circle. Okay? So the exterior angle to a cyclic quad is equal to the interior opposite. So those angles are indeed equal to one another. Exterior angle of a cyclic quad. Okay, I have two parallel lines. That is the transversal, and important, a transversal is a line. Okay, so by implication it's straight. So I can immediately say, they've given me this as x, but it's now also equal to that one. Why? The angles are corresponding in position. They're corresponding angles. There's the transversal. Here lies the parallel lines. Okay, let's see what else they tell us. They tell us that AB, AEC, so AB is drawn, EC is drawn, BC is drawn, where CBC is drawn, and BE is drawn. Perfect. Such that, oh, look at this, EC is equal to BC. EC equals BC, so this line here is equal to that line there, which makes the angles that lie opposite to them equal to one another. So here B3 is also equal to X, which they really didn't have to tell me. They could have asked me to prove it, because that was X and this will be X, angles in the same segment in the cyclic quad. Okay. Let's see what else now. We've run out of information. Now we go and look for the hidden information. We have a cyclic quad. There's my cyclic quadrilateral. I can also say that angle C2, which is subtended by EA, is going to be equal to angle B2 subtended by the same chord. Angles in the same segment are indeed equal. Wow, let's see if there's anything else. I think that's the lot. That's the lot that I can get out of what I've read. Let's see now, now folks, we've been busy for 7 minutes, closely to 7 minutes, to fill out our diagram. Let's see what they ask. They say if EAC, now EAC is this angle, is equal to angle CAB is equal to X. So they're telling us, we gave you those two as X's, so we're just saying that. Give with reasons 4 other angles equal to X. You may not use the same reason more than once. Okay, that's interesting. So let's start immediately. BAEC, we can start off by saying it's a cyclic quad. BAEC, or EC rather, is a cyclic quad. Well, that was given to us. So immediately angle EAC is equal to angle B3 is equal to X. Angles in same segment. So we've used the angles in the same segment that are equal theorem now once. Okay? Now let's go for B1. Remember, we found that B1 was equal to C and was also equal to E2 up there. And they became equal to X. So now we can go via our parallel lines, I suppose, or via our isosceles triangle. But what the point is here, we need to find another angle that's equal. So let's go with B1 equal to X that they gave us, alternate angles. Okay, so AC was parallel to BD, given. And based on that, we can say that B1 is also equal to X, is equal to angle CAB. Alternate angles are equal based on the fact that the lines are parallel. So we've used two theorems now. We've used the angle in the same segment theorem, and we've also used the alternate angles that are equal. So let's just label the angles we've used. We've used B1 there, and we've used B3, and B3 came from there. Now we can argue that BC and EC were given equal. BC is equal to the length CE. That was given to us. Therefore, angle B3, which we have already established is equal to X, is now equal to angle E1. Why? Those are angles opposite equal sides, and we know that those angles are indeed equal to one another. Okay, so we've got that angle in our sights. Now folks, that's exactly what we wanted to have, is that relationship over here and that angle over there. We've got three different reasons why we made things equal. Okay, so now you can go on and you can say, fine, we've already used those lines that are parallel. We've established that. So here we can also say, and angle EAC, angle EAC is equal to angle EDB is equal to X. Those are corresponding angles equal. Okay, so we've used that one as well. B1, remember, was equal to C1 and was also equal to E2. So we can, in fact, search for ways to get to our tan chord theorem as well, because our tan chord theorem gave us angles that are indeed equal to one another. Why was B1 X? B1 was X because of the angle A. So once you've got B1, which we had over here, we can also have used the fact that B1 is equal to angle E2, which is equal to X because of the tan chord theorem. We're now on angle 5 already. Okay, we've only asked for 4 of these. If you wanted to use C1, you could then have argued that E2 is equal to C1, angles in the same segment, but we've already used it. So I think we've met the criteria that the question set. Now they're asking us prove that AC, so in other words this line, I'm just going to do this so that we can visually see that quite clearly, is a tangent to the circle through A, B, and D. So that would mean that that's the tangent and this is the chord, that those two angles are equal, and we know that they are. Okay, but how did they become equal to one another is how we have to argue, and that is for 2 marks. Okay, so what did we do? We haven't used angle A2 here. And where is angle A2? Let's just decide what we're going to number these as. That's angle 1, this is angle 2, and that's angle 3. But if your angles aren't numbered, folks, I don't suggest that you put numbers in there. You use the notation they gave you. So if we want to use this angle, we're going to call it CAB. Okay, so CAB, that angle here, is equal to the angle, let's see which angle is equal to this angle here, that one over there. So we want to prove that this is equal to D. That's where we have to get to. Okay, so I'm going to say these two angles were given equal, therefore those two are equal because of the corresponding angles. We've already linked these two angles, so we can say EAC, angle EAC. Oh, let me try and zoom out so you can see the whole picture. Okay, angle EAC is equal to X is equal to angle D. We've proven that above. Okay, we've already used this. But EAC is equal to CAB. That was given to us. Okay, so I'm saying these two are equal, given to us, but that's equal to that. Therefore, this angle is equal to that one, therefore this must be a tangent. Okay, so therefore, angle CAB is equal to angle D is equal to X. Now, folks, please, very important, your reason here is sorry, that's what we've proven, what we've stated. So our conclusion will be that CA is a tangent to circle ADB. And our reason would be not the tan chord theorem. This is the converse tan chord theorem. Okay? It's not the tan chord theorem, it's the converse tan chord. And without the word converse there, you're not going to get the marks. So this is 8 marks. The key thing here was you may not use the same reason more than once, and the key thing here is your converse tan chord. Now, those of you that believe geometry is difficult, folks, it's a fallacy. It's not. You use your relationships in your diagram to establish what the layout is going to be, to follow your reasoning through when you explored this diagram to try and get to what they want you to do. You don't look at the question after you've at least spent 5, 6, 7 minutes on that. So it took us as long to analyze the diagram than what it did to answer this question. That's the first geometry question, question 6.